expand tan pi over 4 plus h in the Taylor series as far as the term in h raised to 3 Roman 2. Use the results in 1 above to determine the value of tan 47.5 degrees correct to 4 decimal places. 10 marks. Now this is the question that was, it's a KNEC question that was done in October, November 2021 by mechanical technology, by Diploma in Mechanical Technology Module 2. It was question 1B, Roman 1 and 2. Now they want us to use the Taylor series to expand this one in Taylor series up to h raised to 3. Now first of all, we need to study the Taylor series. F of x plus h is given by f of x plus h times f of x prime plus h squared all over 2 factorial f of double prime plus h cubed all over 3 factorial f of triple prime, and it continues like that. Now that they have asked us to expand up to h raised to 3, we can stop at that point. Now our f of x in this equation equals to, we've been given tan pi over 4 plus h. Now for us to expand this equation, the first thing we shall let or put h equals to 0. So when we put h equals to 0, this equation becomes, remember we have put this h equals to 0. Therefore this equation becomes f of x equals to tan pi over 4. Now I'm going now to expand this one, but for convenience of working, I want to let pi over 4 equals to x. Therefore I have f of x equals to tan x. So once I'm through with the expansion, I'll go back, and where there is x, I'll replace by pi over 4 after calculation. Now we need to get f of x prime, f of x double prime, and then f of x triple prime. Once we get them, we come and insert them in this equation. Now how do I get f of x prime? You differentiate tan x, and remember tan x is the same as sin x all over cos x. So we are going to differentiate this one. So this will be equal to, here we apply the quotient rule. We put down the bottom, which is cos x, and then differentiate the top, which is sin x. When you differentiate sin x, you get cos x, then minus, we put down the top, which is sin x, and differentiate the bottom. When you differentiate cos x, you get minus sin x, then over bottom squared, which is cos x squared. So this equals to cos x times cos x, you get cos x squared, and then we have minus sin x times minus sin x, we have plus sin x squared all over all over cos x squared. Now from the fundamental identity of trigonometry, cos x squared plus sin x squared is equals to 1 over cos x squared. Then you can also remember that from trigonometric ratios, we know that 1 over cos x equals to sec x. Therefore, this one would be equal to 1 over cos x squared would be equal to sec x squared. Therefore, we are saying that f of x prime equals to sec x squared. So we have that. So we need to get f of double prime. Now for us to get f of x double prime, we differentiate sec x squared. Therefore here I will let y equals to sec x squared and u equals to sec x. Therefore where there is sec x, I replace with the u, but because it's squared, so it will be y equals to u squared. Then I differentiate y with respect to u. dy du equals to 2u. Then I will differentiate u with respect to x. Now u equals to sec x, which is the same as 1 over cos x. Now to differentiate u with respect to x, we apply quotient rule. You put down the bottom, which is cos x, and then you differentiate 1 with respect to x, you get 0, minus we put down the top, which is 1, and you differentiate the bottom with respect to x, you get minus sin x all over bottom squared, which is cos x squared. So this equals to, this is 0, minus 1 times minus sin x, we have sin x all over cos x squared, which equals to sin x all over cos x squared is the same as sin x all over cos x dot cos x. So sin x all over cos x dot cos x is the same as 1 all over cos x times sin x all over cos x. But 1 all over cos x is sec x. Sin x all over cos x is tan x. So when you differentiate sec x, you get sec x tan x. So what we are saying here is that this is du dx. We are getting du dx. So du dx equals to sec x tan x. But chain rule, dy dx equals to dy du dot du dx, which equals to dy du is 2u dot du dx, which is sec x tan x. So this equals to, but what is u? U is sec x, so here you have 2 sec x dot sec x tan x equals to 2 sec x squared tan x. So what we are saying, therefore, our f of double prime equals to 2 sec x squared tan x. So we have gotten f of x double prime. So we are remaining with f of x triple prime. So how do we get f of x triple prime? We are going to differentiate f of x double prime. F of x double prime, which equals to sec x squared tan x. So for us to get this, we differentiate this equation again, which equals to, of course, I'll take 2 out because it's a constant. Then here we are going to apply the product rule because we have sec x squared tan x. So what does the product rule say? We put down the first, which is sec x squared. Then we differentiate the second. When you differentiate tan x, you get, of course, we have already done it right here. When you differentiate tan x, you get sec x squared, which is this one. Therefore, we simply write it here, sec x squared, then plus. We now put down the second, which is tan x, and differentiate the first. When you differentiate sec x squared, already done it here. When you differentiate sec x squared, you get 2 sec x squared plus tan x. So here we get, so I can write it here, plus tan into now this tan x. We put down the first, the second, and differentiate the first. So when you differentiate sec x squared, you get 2 sec x squared, then tan x, like that. So this equals to 2 into this one will be sec x raised to 4, then plus, here we have 2 tan x squared sec x squared. When you open the bracket, we have 2 sec x raised to 4 plus, this will be 4 tan x squared sec x squared. So this is our f of x triple prime. Now from the equation, you can see we have gotten all the constants, so we can come and replace them in this equation. So we shall say that this was tan x plus tan, so we have tan x plus h equals to, now we have f of x plus, now h dot, now our f of x prime, which is our f of x prime, which is sec x squared then plus h squared all over 2, or 2 factorial, this 2 factorial, f of x double prime, which is 2 sec x squared tan x, which is 2 sec x squared tan x. Then plus h cubed all over 3 factorial, and then our f of double prime, which is this one, dot 2 sec x raised to 4 plus 4 tan x squared sec x squared. So equals to, it will be equal to f of x plus h sec x squared plus, now 2 factorial is the same as 2 times 1, so these two will cancel that 2, and then we remain with h squared sec x squared tan x, then plus, now here you can see we have 2 and 4, we can factorize out 2 from this equation, we take out 2, so here we remain with the 2. Now 3 factorial is the same as 3 times 2 times 1, so these 2 will cancel with these 2 here, and we remain with now h cubed all over to be 3. Now here we have sec x raised to 4, here we remain with the 2 tan x squared sec x squared. So at this point I now want to replace the value of x. Remember here I say that for convenience of working, I had let x equals to pi over 4. Therefore, this would be equal to, now this would be, but what is f? F of x is now tan pi over 4 plus, now this is h sec pi over 4 squared plus h squared sec pi over 4 squared, it's continuation here, tan pi over 4, then plus h cubed all over 3 into sec pi over 4 raised to 4 plus 2 tan pi over 4 squared sec pi over 4 squared. So remember now this is tan pi over 4 plus h, so we have tan pi over 4 plus h now equals to, now pi over 4, can use our calculator, tan pi over 4, pi over 4 is the same as, because pi is 180, divided by 4 is 45, therefore it's like we are getting tan 45 equals to 1. So tan pi over 4 is the same as 1, then plus h, this h, sec pi over 4, now here sec sec pi over 4 squared is the same as 1 all over cos pi over 4 squared which equals to, now we get here cos pi over 4 is the same as we are getting cos 45 squared by 1 divided by cos 45 squared. So first of all we get cos what? Cos 45 is equals to root 2 all over root 2, and then we square it. We square the answer, we get 1 all over, this is 1 all over 2. So you have 1 divided by a half, so you have 1 divided by the answer, we get 2. So this one equals to 2. So we are saying that sec h sec squared sec pi over 4 squared is the same as 2. So this is 2. Then plus h squared, now sec, this is now 2 dot 2, then tan pi over 4 is 1 dot 1. So we are through with this. Then plus, this is h cubed all over 3 into sec pi over 4 raised to 4. So sec pi over 4 raised to 4 is the same as 1 all over cos pi over 4 raised to 4. So we get cos 45 equals to root 2 all over 2, then raised to 4. So answer raised to 4, we get 1 all over 4. So we take 1 divided by 1 all over 4. 1 divided by the answer, we get 4. So what we are saying is that this is 4. This sec pi over 4 raised to 4 is 4. Then plus, this is 2. Tan pi over 4 squared, tan pi over 4 is the same as tan 45, which is 1. 1 squared, we have 1. Then dot sec pi over 4 squared, which is 2. So here we have tan pi over 4 plus h equals 2. So we shall have 1 plus, this is 2h, then plus 2 times 1, we have 2h squared, and then this 2 times 1 times this is 4 plus 4 is 8. So plus 8 h cubed all over 3. So at this point we have expanded. I think we have now done with Roman 1. Expand tan pi over 4 plus h in Taylor series as far as the term in h cubed. So we are through with Roman 1. Then Roman 2, use the result in 1 above to determine the value of tan 47, correct to 4 decimal place. Now tan 47.5 decreases the same as tan 45 plus 2.5 decrease is the same as that. So it's like now from this equation we already have tan 45. So the tan 45 we already have. So what we are lacking is we need to get this h, and h is 2 point what? H is 2.5. So we change this one into radians. So we know that 360 degrees equals to 2 pi in radians. What about 2.5 degrees? So we shall take 2.5. We take 2.5 divide by 360 times 2 pi. This equals to 0.043633. So we are saying, and remember this is our h, so we are saying that h equals to 0.04633. Therefore, tan 47 half degrees will be equal to, now we have 1 plus 2 times this h, which is 0.043633 plus no, we can't write it here. Tan 47 equal to 1 plus 2 times h, which is 0.043633, then plus now 2 times h squared, 2 times 0.043633 squared, then plus it is now, which is 8 times 0.04633 cubed all over 3. Let us now see. So we have 1 plus, we take 2 times 0.04633 is plus 0.087266 plus now it will be 0.043633 squared times 2 plus 0.03877 plus now we have 0.043633 cubed times 8 divided by 3. 0.0002215. Then we can add all of them, plus 0.0038077 plus 0.087266 plus 1. So this equals to 1.091295. Remember they wanted to 4 decimal place 1, 2, 3, 4. So this will be 3. So this equals to 1.0913. Then we can confirm with the calculator whether we are right or not. We get tan what? 47.5 is 1.0913. So we are correct. Now, so when you've been given this kind of equation, the first thing you need to state the Taylor series up to where they have required us to expand. For example, this one they wanted us to expand up to h raised to 3. So once you have stated that, then you now expand your f of x. In our case here, our f of x was tan pi over 4 plus h. But before you do that, you need to put h equals to 0, so that you are now only going to expand what? Tan pi over 4 up to h raised to 3 here. So you need to get f of x prime, f of x double prime, f of x triple prime, meaning you are differentiating tan pi over 4 3 times. You differentiate for the first time, you get f of x prime. You differentiate for the second time, you get f of x double prime. You differentiate for the third time, you get f of triple prime. So once you get them, you come and replace in this the way we have done. Then you proceed through and then you move through the way you have been working until you get the now expansion for Roman 1, and then using that now you can now be able to get tan what? Tan 47 by applying the answer in the Roman 1. Thank you for watching and listening.